So if we want to talk about end behavior, let's start off with some really simple ideas and some simple graphs. So let's start off with the idea of x squared here. And the idea of end behavior is looking very far to either end, either to the left in the negative direction on the x-axis or to the right in the positive direction on the x-axis. And we're going to look at both. And just to make it a bit more clear here, what I'm going to do is I'm going to change this x squared to 0.1 x squared just because it makes it nice and wide. And it's a little bit easier to see what's going on there. Okay, so let's go ahead and maybe look at the left side end behavior. So if I look very far to the left in the negative direction, and as my x's get really far to the left, or as my x's approach the negatives, the really, really big negatives like negative infinity, then what's happening with the y values? So as I go more and more and more to the left, what's happening with my y values? Well, it looks like they're getting higher and higher and higher. So it looks like my y values are actually going up and up and up and up, so they're actually approaching positive infinity. So my y values, or my f of x values, because f of x and y are really the same thing, are getting bigger and bigger and bigger. And if I were to do the same thing, but this time look to the right side, so this time I'm going to look on the x-axis and I'm going to go all the way to the right. So I'm going to look on the x-axis, and as those x values get bigger and bigger and bigger in the positive direction, so go towards 10, 100, 1,000, and a million, get bigger and bigger in the positive direction, then what is happening to my y's? Let me see, let me get one more color here. So what's happening to my y values? Well, my y values are getting larger and larger and larger and larger, so they're going up and up and up and up. So my y values are getting bigger and bigger and bigger, and y is the same as f of x. And so I can kind of state this in mathematical notation. And let's see here if I can zoom out on this graph. There we go. And so as I zoom out, we can really see kind of this exaggerated. So in the big picture, when I go really, really far to the left, so when I look at the very, very negative values, what's happening with my y values? My y values are getting bigger and bigger and bigger and bigger and bigger. And so if I were to go way out here, towards negative infinity, my y values would be way off the graph here, way, way up. And then same thing in the right direction, or in the positive direction. If I were to look in the positive direction, what's happening to my y values? That are going up and up and up and up and up, really high. And let's go ahead and do the same thing with a different graph. So this time I'm just going to focus on x cubed, an odd function with an odd highest exponent, because its end behavior is opposite. So it changes whether we're looking to the left in the negative direction or to the right in the positive direction. And again, what I did is I just made one with a 0.1 behind it, because it just basically makes it wider and just a little bit easier of a visual to take a look at. So first of all, let's go ahead and look to the left. So again, always using the x-axis. And if I look to the left on the x-axis, then I could write that in mathematical notation by saying as the x's approach, well, what are they approaching here? It's going to -5, to -10, to -20, really, really far, to -100, -1,000,000. So as the x's approach, of course, we can't reach negative infinity, but we can approach it. So as that happens, then what's happening with the y values here? Basically, are they going up to positive infinity or down to negative infinity? And in this case, as I look to the left, well, they're going down. So then I would want to say the y values, and again, kind of a fancier way to say y values is the f of x values. So the y values, or the f of x values, the heights, are going down, 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 down. So the y values are going to approach negative infinity because they're going down and down. Okay, so now as I look to the right, let's see what's happening over here. So as I look to the right, well, look to the right, that's like saying x approaches positive infinity, because where am I going here? I'm going towards 5, towards 10, towards 20, 100. So I'm going really far to the right. And as that happens, then what's happening with my y values? Well, my y values are going up, up, up. So again, fancier way to say y values is f of x values. So my f of x values or y values are going up and up and up all the way towards infinity. So essentially, I can start off with this same kind of skeleton here, and there's really only one thing that I need to actually plug in here, because I'm always going to be looking to the left and seeing what's happening with my y values, and then I'm always again going to be looking to the right and again seeing what happens with my y values. So when I look to the left, that's like saying your x's are getting really small. So look to the left, like x goes towards -5, -10, -100, -1,000,000, goes towards -infinity. And then I would need a graph to see, well, what happens to my y values to fill in this little spot right here. After I do that, I will look to the right. Looking to the right is like saying, well, your x's are moving to the right. So that's like moving towards 5, 10, 100, 1,000, all the way towards infinity. And then again, I would need a graph to be able to fill this in. But I can always start with this same skeleton, and that's kind of my instructions. And so really, when we say that x, let me get this right here, x approaches -infinity, that's like saying, just in mathematical notation, that I'm looking left. So you don't actually need to write this look left, because you're already saying it right here. And then same thing down here. When I say x approaches infinity, that is saying look right. So we don't necessarily need to say look right, because I'm already technically saying look right right here. So now let's go ahead and bring in a graph. And let's do the look left. So the look left, or the x approaches -infinity, is really saying the same thing. So that's saying let's go to the left here. And not just anywhere on the left, but really far to the left, towards -infinity. So as I go towards -infinity, then what's happening with my y values, my heights? So my y values, my heights, my f of x, those are all the same thing. So basically, are they going up or are they going down? Well, they're going up and up and up and up. So they're going towards positive infinity. So positive infinity is going to be the thing that I'm going to fill in there. And that's really kind of the only thing that I need to fill in. Okay, now let's do the bottom part. So the bottom part here, where it says to look right. So let me get the highlighter. Okay, where it says look right. So look right, again, mathematically, that's like saying x goes to positive infinity. So if I say x goes to positive infinity, then the question is, what happens with my y values? What's happening with the heights? And if I look, when I look to the right, what's happening with my heights? My heights are getting lower and lower and lower. So my heights are going down, 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 down towards -infinity. Okay, another example here. And when I say, or maybe when I think look left, what we're actually saying in mathematical terms is the x values on the x-axis are approaching -infinity. So look left, look where your x's get really, really small. Then the question is, what's happening with your y values? So what's happening on the y-axis? Well, on the y-axis, my y values are getting really, really small. So they're approaching -infinity. Similarly, when I'm thinking look right, mathematically we can say our x's are approaching infinity. So as I look right, as I look to where the x values get really big, then what's happening to the y values? Well, my y values are getting small. They're going towards -infinity. So, maybe it's around -6 or something where I left off, and then it would keep going down towards maybe -10, -20, and it's going to continue in this fashion to get really, really, really small. So that's going to approach negative infinity. So we'll do one more, and you'll see that there's really not a whole lot of variation because I'm essentially just looking left and saying, does it go down or up? And then looking right and saying, does it go down or up? And once you have this skeleton to work with, if you really understand kind of what this skeleton is and how it works, again, remember that we don't need the graph to start with that skeleton. So I can start with this setup no matter what the question is or what the graph is. So first thing I'm going to do is look to the left. And again, I don't need to write look to the left in words because I'm writing it in notation like this. X approaches negative infinity, and that means to look left, go to the left. Then the question is, what's happening with the y values? Well, when I look left, my y values are going down. They're getting really small. And the further left I look, the closer I get to negative infinity, well, the further down my y values go. So as I go really far to the left, my y values are going to get really, really, really low towards negative infinity. Okay, now let's go ahead and look right. So let's look right mathematically by saying x approaches positive infinity. So going to the right, or saying my x values go towards positive infinity, let's go ahead and think about what happens with my y values. Well, my y values are going up and up and up and up, really, really high, and they would continue. The further right I go, the further they will go up. So this is going to approach positive infinity.